My name is Naga Chandrasekharan, and I'm Senior Vice President for the Technology Development Group. My colleagues highlighted the memory hierarchy and the triangle that we used through the whole presentation. And my job is to build the foundation for that whole memory hierarchy. As part of the Technology Products Group, we are involved in developing the different silicon-based technology, as well as getting them into our system products so that we can get it to the customers. This section is still under the safe harbor statement. I just wanted to remind everyone. As Raj kicked off the presentation, and then Ryan, Malcolm, and Roger highlighted, the requirements for memory within the overall hierarchy is expanding. And with that, the performance bandwidth requirements for both our DRAM and NAND products is continuing to increase. As Malcolm indicated, we are moving to DDR5, and with it, our speed, the data rate speed, is now in the 6400 megatransfers per second and continuing to increase. And on the NAND side, we are moving from our 3-bit per cell to quad level cell to continue to increase the performance levels, but also improve the overall cost. So this paradigm of continuing to demand a higher performance while we can deliver lower power and lower cost is driving a need for significant innovations. So within Micron, on both the NAND side and the DRAM technology, we have been continuing to drive advancements through our innovation engine to make sure we can meet these performance requirements while driving towards node over node cost improvement as well. And with it, one of the big things that we are looking at is also packaging technology, where both the heterogeneous and homogeneous package technology is now enabling advanced solutions, from a multi-chip package that goes into mobile solutions, and also the high bandwidth memory, where we are taking our TSV technology and stacking the DRAM dies to meet the bandwidth at a lower power, which cannot be gotten in the same footprint by just using our DDR5 or the graphics solutions. And this whole technology scaling path that we are driving is built on our innovation of over 40 plus years. And this shows just a few exhibits of some of the innovations that we are driving from our silicon and system solution. I'll just highlight two of them. We are very proud of the pitch multiplication technology that we introduced in the NAND industry back in 2007, where the industry was dependent on a lithography-based scaling path. And Micron came up with the first pitch multiplication technology, which is still benchmark in our overall portfolio and in the industry, that drove the NAND technology scaling to the next level. And today it's used in DRAM and across the semiconductor industry pretty widely. And more recently, we introduced the PAM4 multi-level signaling capability into our graphics products, which is again doubling the data rate that we are able to get, driving more user experience improvement with our graphics product, and also bringing in a higher data rate transfer. With this innovation today, Micron's in the leadership position with respect to both DRAM and NAND technology. Towards the end of last year, we announced our 1 alpha DRAM technology, and this is the smallest cell size in the industry. In fact, for the last 2 to 3 DRAM nodes, Micron came out with the smallest cell size and the first to come out with that cell size in the industry. And with 1 alpha, we are actually able to get a 40% bit growth from our prior technology nodes. And it's not only benchmark in terms of cell size and the cost position that it provides, but it's also providing a lower power for our mobile DRAM solutions. And it's going to be a higher speed DRAM available across our portfolio. The production is already going at full speed, and we are getting this to our customers and working very close with them. On the NAND side, we announced our 176-layer NAND. And once again, this is industry leading in terms of the number of tiers and providing a great cost position, but also getting to a good power efficiency and better sequential and random read and write solutions. It's a 33% higher data transfer rate. So with both our DRAM and NAND, Micron is in a technology leadership position that's building that foundation for us to continue to expand our product portfolio across the memory hierarchy. And it's not only the traditional DRAM and NAND, it's also across a multiple spectrum of emerging memory landscape that we are looking at. As NAND continues to drive the lowest cost memory solution provider, and it moves towards a storage plus type applications, DRAM continues to improve on the data transfer rate, and it's the highest performance-based memory. And in this space between performance and cost, we are looking at a variety of memory solutions, like the team pointed out, where we talk about near memory and as well as bandwidth memory and capacity storage. We are making sure across the fundamental silicon-based technology, we have all technologies evaluated and can position them to meet the requirements of this memory hierarchy. And the one thing I want to highlight is with the high bandwidth memory, we could eventually get into a space of continuing to do even in memory processing, where we can build in more optimized AI algorithms that are suiting into this individual memory solutions that we have within the high bandwidth memory. And to do this, I pointed out the innovation that we are doing. And this is one example of the breadth of innovation that we are driving from a silicon technology, from a process solutions, because of the scaling that we are doing to drive form factor reduction, as well as trying to get more die per wafer. We are continuing to challenge the parasitics and improving the metallization schemes that can drive to better resistance capability. And this drives more complexity. As you can see, the scaling drives smaller and smaller dimensions, but we still have to get faster speed and better read times and write times with our solutions. That drives advancements in the materials technology. And I tell this to all the university students that if you're a material scientist, this is the golden age. It's if I take a periodic table, we have pretty much looked at every material on the periodic table and continuing to push the limits of technology here. And it's just exciting. And then we go to process margins. It's threading hundreds and hundreds of needles with almost limited pinhole through which we have to drive our processes. And our goal is to take this needle hole, but expand it to where we can drive a truck through it. And we drive a lot of innovation in that area through new materials, working with our supply chain on the equipment technology. And the equipment technology is becoming a critical portion of driving our scaling roadmap, but at the same time, keeping the overall bit cost lower with every node. So significant amount of innovation from plasma physics to new materials, chemicals, and gases, and to process technology that we can drive our innovation. When I talk about process technology, I want to kind of connect the whole circle together. Raj started with data economy and data insights and how the entire industry is being enabled now, and new applications are coming in because we now have this data. And memory is playing a key role in enabling this data insight. And we are now seeing how we can bring it back within our own technology development and factory. And across the value chain, data is going to accelerate our rate of innovation. Starting from design technology, how can we get to better power efficiency? How can we get to smaller die size, but at the same time, improve our signal integrity? How can we get to more reliable products, which is becoming a critical cornerstone, the quality of these products with memory, as they are becoming a critical portion of the hierarchy. So starting from design, using data analytics to do validation and verification of our design, placement of different circuits, and also the signal to noise ratio, how can we improve? And then moving to the silicon system, like I talked about, threading hundreds of needles, we have to see how we can improve our process margin. And we are using data to generate insights. The semiconductor factory is actually generating terabytes worth of data on a daily basis. With all the equipments that we have and the data we collect, we can now generate insights with very low latency. If we can have faster algorithms and using our own memory infrastructure, can we get these insights at a faster rate? And it's not just Micron, but everyone is starting to move in this direction. And this could be a competitive advantage in how we use data to generate faster insights to drive faster scaling. And then moving to systems, working with customers to see how the products are being used in the customer landscape, and very close partnership because the defects are dependent on different use conditions. The same memory and the same system based on the use condition could have different behaviors. So working in close partnership with our customers to understand their use models and looking at the data and connecting it back to our own entire value chain and seeing how can we improve the product reliability and the overall experience that the system sees with memory in the hierarchy. We have seen faster time to maturity for our yield, which is going to help us with the efficiency of the factory, fewer quality events because we can detect issues earlier, but more importantly, faster time to solution and time to market. So closing that whole circle where we started with data bringing insights, we are seeing the same data insights now driving this technology scaling. And I'm confident it's going to drive the memory scaling for the next several decades. And with all the growth in memory, all the growth in semiconductor industry that we are seeing, we haven't forgotten the fact that we have to grow in a sustainable manner. This growth brings a lot of responsibility to us as technologists to make sure the technology development is sustainable. While I'm very proud of the periodic table and all the materials we are looking at, we also need to make sure that it is sustainable. And we are making sure as part of this whole month when we are celebrating the Earth Day and sustainability, that Micron is playing a very important role with respect to corporate sustainability. And one of the things we are very proud of is our efforts with operational sustainability. And we announced recently our aspirational goals from emission, reducing the emissions by 40% relative to our calendar year 18 timeline. And this is very challenging. It looks not as big of a number, but we are scaling and we are adding more bits per wafer. And the overall bit growth is so high, but at the same time, we also want to reduce the total emissions, and it requires significant innovation. We have an aspirational goal to get to renewable energy, 100% of our operations. Water, this is very close to me in terms of the amount of water we use, we recycle and recover, and both in our operations as well as in the communities where we operate, we are taking huge efforts to drive improvements in water usage efficiency and then waste. And we are doing this through data collection within our factory and using that data to generate insights and say, how can we improve our operational efficiency? That's not only a good corporate citizen, but it leads to our top line and bottom line improvements because sustainable operations, better operational efficiency means better cost. And the last point that I want to make is all this innovation then leads to our products being more efficient. We are driving speed, but at the same time, the energy per bit has to be lower. And we keep making sure through our design and process innovations, we drive power efficiency within our products so that our customers can see improved power usage.
How much is the spending every year for Micron in R&D? I mean, compared to the revenues.
We report this as and we have targets, and it tends to change, of course, based on the revenue that we look at. But we typically have the target of in the 10 to 15% of our revenue for the R&D operations spend. But of course, R&D and the whole technology is foundation to any technology company. And we make sure we are investing heavily within our, for our overall R&D roadmap.
So I have a question that maybe it's not a technology question, but every vendor in the chip industry is reporting, a shortage of, chips. I mean, we read this news every day. And how is it impacting your roadmaps and, and your ability to grow in this period?
Yeah, I'll answer from the roadmap, and Raj, please take the question on the demand or supply side of it. Enrico, from a roadmap side, it's really not impacting us. We are continuing to drive our technology roadmap when it comes to having the leading edge products and the capabilities that we are making sure we drive the technology roadmap from both the performance requirements, but also the bit growth that we are able to generate through technology transitions on our wafers. And that's a big part of our consideration, is to make sure that the bit growth that we drive on our wafer is in line with where the industry requirements are, and balancing that with our cost reduction requirement and meeting the performance needs. So the current situation is not impacting our technology roadmap from the fundamental things that we need to do to keep the semiconductor technology progressing forward. Raj, on the supply, please go ahead.
Yeah, so as Naga said, the drumbeat doesn't change because there is currently a very tight supply of semiconductors across the spectrum. And things even related to products that semiconductors are built out of but need other components. So, we're seeing a very tight market for, particularly for DRAM, and in an industry that is traditionally cyclical in terms of its the demand supply balance. For us, as we've said publicly, it is a tight market, but our customers are trying to manage their supply chains as well as they can. In some cases, there is significant tightness. I think if you looked at what the president's conference that he did at the White House a couple of weeks ago, in which Micron participated, our CEO participated as well. There are sectors of that economy, particularly like automotive, which are particularly hard hit at this point. And from our perspective, as long as we are trying our best to meet the demand, it's a good problem to have. Although we recognize for our customers it is a problem. And in many ways, it isn't really affecting the fundamental direction of our business, not the roadmap, but it is. We are being nimble about listening to our customers, remixing products, trying to understand their pain points as it comes to their challenges with growth, and doing the best we can to sell every bit we create out of the engine that Naga just described.
So I noticed that, from basically what you guys report to the street, about 66% of your business is coming from the DRAM, side of the business, and about 32% coming from NAND. Do you see adoption in CXL changing kind of the layout of where you expect revenues to come from in the coming years, or is it that kind of what the expectation would be?
I think to the first order, what we report as our split of revenues is driven by the state of the industry in DRAM, but that is both the market and the supply side. The NAND side is not as consolidated as the DRAM side. And the market demands are fundamentally different. And in fact, profitability of those two segments are different as well. We see CXL as fundamentally advancing the platform infrastructure to a point, like Ryan was describing in detail, that more interesting and useful system architectures that can be built. We expect that is going to continue to accelerate the rate and pace of use of memory and storage as well, but first and foremost, memory. In a way, because it just end users can just derive more value based on those innovations. And so the demand will continue to go up. The fundamental driver of that is CXL is a path to that. The fundamental driver of that is data. As there is more data to deal with, as there's more data to store, to compute on, and even move between servers, that data growth is the fundamental underlying systemic growth of our business, both in DRAM and NAND. and innovations like CXL for the industry allow for quantum jumps in value being delivered through targeting of architectures that can solve problems today that couldn't be solved 2 years ago.
As your company moves deeper into storage, and also, using the CXL, who are you encroaching on, and who's encroaching on you?
So obviously there's a limited number of NAND manufacturers in the world, and we're all putting out SSDs. Now, what's interesting about Micron is that we have a full portfolio that's in multiple segments. So whether it be in the consumer segment under a Crucial brand, in the client OEM segment, or the data center segment. It's a very, very broad portfolio. At this point, we actually don't see new market entrants. If anything, in the storage side, we see some signs of consolidation driven by some recent M&A activity. So we think that Micron's very well positioned in this market. We're going to continue to invest in our NAND roadmap. And one of the most interesting things that Naga mentioned is the fact that we have a significant leadership advantage with our latest 176-layer NAND. So we're out in front in terms of the technology and then building that into our storage subsystems. But there's nothing that we envision on the storage side that's coming that would disrupt the Micron business or business model.
To repeat what Roger said is kind of the same story in the near and now and here, rather, future for DRAM. It is also three major players. There are companies, in China that are investing heavily because of the value in this segment. And that's just part of standard natural competition to us. I think the more interesting debate we can have about this notion of changing roles is as we look down the line at the blurring of the model of compute happens here, data is stored here, whether it's memory and storage, to when we start talking about either compute in memory or compute in storage, again, driven by this need to process data more efficiently, more so than ever before. And those architectural shifts then will raise the question of, where does compute happen relative to the memory, or where does memory stay relative to compute? And those are fairly significant architectural debates, right? That are going on today of actually, in many cases, showing that with some amount of compute being added to memory, which is essentially a memory, but now with compute capabilities, I think Naga made a reference to it a little while ago, you can do some very intelligent things without dragging all of that data all the way to a CPU, which is what you do in a traditional infrastructure. On the other hand, there are compute models, particularly driven by things like Petri nets or directed graphs, where you can say, well, it's a compute framework, but if you add more memory at right points in that graph of compute, if you will, then suddenly you get far better performance than trying to have to fetch and marshal the data across all those compute nodes. So as we look at and innovate and participate in those kind of architectural shifts, the question you raised becomes probably more relevant, and you will see the opportunity for changing roles. The good thing for Micron is we have the portfolio and the core technology to be able to participate and lead in those shifts.
At what point do you see the storage architecture changing so dramatically that the application layer is going to have to get involved with architectural changes to be able to embrace the change?
Our view is that, if we could deploy new technologies and new capabilities that are more evolutionary in nature, the velocity of adoption tends to go up, the pace of adoption and the deployment is much, much better than very significant changes, especially when you talk about application layers and the fact that you have to do this massive enabling activity. What we're seeing is the hyperscalers, the very large ones, are driving a lot of the innovation in the storage subsystem because they're vertically integrated and they control the application layer all the way down to the bare metal. And then we see that can come out into the industry. We tend to overestimate the front end ramp of new technologies and underestimate the back end tails. And so in traditional enterprise, we see that storage evolution and the changes at that point are significantly slower. So at this point, our view is industry standards and incremental change as we move forward in time versus major disruptive changes if we can avoid it.
Yeah, a little comment to that. I would say don't be afraid to take a gamble, based on the beginning of the presentation. Some of these technologies, from my perspective, I work in the Microsoft data space, the amount of change can be so significant that it can be worth the pain to adjust certain processes to take advantage of it. For example, we were playing with Intel PMAM at one particular site. This absolute bare of a mission critical process we took from 8.5 hours to 8 minutes. With a very small change in application code. Don't be afraid to take those kind of gambles, and I'd love to see it from you all.
Yeah, I completely agree with you, David. That's a great comment. But the key that you just said is very small changes in the application code. My commentary is when we say we have to rewrite application code or redo application code, that's where you get disruptive. But we're releasing new technology. It's very, very disruptive. And if we could do it without affecting that application layer, that to me is a win-win.
And this is a place, David, where, given that what you just referenced, right, our partners and end customers are also trying to find that right space, right? As new technologies define what could be landing zones, right? They are trying to look at how to deploy it. So as CXL moves forward and in the 3.0 version provides pooling, now suddenly the way you look at warm memory and the way you look at cold memory, which now may be pooled across racks even, has a very different value proposition. But that's not a static value proposition. If you can continue to increase performance and drive costs down, again, it's that hierarchy where the technology innovation can shift it on that curve and actually be used for things that were different than what it was designed for in the beginning. And that's the exciting part.
It's a lot of fun, so keep it up.
Naga told us about emerging technology, so ReRAM, STT-RAM, and ferroelectric RAM. And I was a little bit distracted, so maybe he already answered my question. Do you have a time frame when this technology will be available broadly in the market?
I mean, obviously, we continue to work on this emerging memory technology, and we continue to make progress. So not a specific time, but we continually look at it. And as we make progress in the technology and as and when our application space requires it, we will introduce it.